There are two special right triangles that are really important when we talk about trigonometry. They have other uses and lots of them, but the ones that we're going to talk about most for trigonometry are 30, 60, 90s and 45, 45, 90s. And what I need you to understand is if you have a 30, 60, 90, there are certain ratios that will exist for the side lengths. And if you have a 45, 45, 90, there are certain ratios that will exist for the side lengths. So what I'm going to do is in this first video is just show you where 30, 60, 90s come from and where 45, 45, 90s come from. There's this place called this room to show informal proof. There's lots of proofs for 30, 60, 90s and 45, 45, 90s. These are the ones that make the most sense to me. So that's what I'm going to share with you guys. For the 30, 60, 90, what I want you to think about is if you had a equilateral triangle. Now, equilateral triangle means that all three sides are identical. And this is going to be a little bit weird, but I'm actually going to label each of the sides as 2x. There is a method to my madness, I promise. And each of the angles, because it's equilateral, it's also equiangular. So each of the angles is a 60-degree angle. All right, so that's the basic idea behind a equilateral, equiangular. It's a regular triangle. Now, that's not a 30, 60, 90. What I'm going to do, though, is I am going to bisect it. I am going to draw in an altitude here. Now, to draw in an altitude means that I am going to create a 90-degree angle right here. I am going to chop this triangle directly in half. So this base of 2x is actually going to become x and a separate x over here. And then if this is 60 and this is 90, what's left over for this angle up top is 30 degrees. Okay. So I'm actually going to take this and separate it out. So if I just focus on the triangle, the one on the right side here. So we've got a 60-degree angle here. We've got a 30-degree angle here. So this is x. My hypotenuse is 2x. And that was the reason I used the 2x, is because I knew I was going to chop it in half, and it makes it a lot easier to deal with the 2 versus a 1/2 later on. Now, I want to find the third side. So knowing that this side is x and this side is 2x and I'm dealing with a right triangle, I can use Pythagorean theorem. It's going to look a little bit weird, but that's okay. So I'm going to call the missing side a. All right, so a squared plus x squared is equal to 2x squared. So a squared is what I'm looking for. So there's x squared. 2x squared is going to turn into 4x squared if I do my apply the power correctly. I'm not going to say distribute, but apply the power correctly. I am going to subtract x squared from both sides. So a squared is equal to 3x squared. And I actually want to know the side length, so I need to take the square root of both sides. So that's going to give me a is equal to, now this is where I want to break it up in pieces. I have no idea what the square root of 3 is. It's not anything nice and pretty, so I'm going to leave it as the square root of 3. And then x squared here, when I take its square root, is just going to be x. So this altitude here, this side across from the 60-degree angle, is x root 3. So your ratios for 30, 60, 90. The side across from the 30 is always x. The side across from the 60 is always x times root 3. And the side across from the 90 is 2x. So what this means for us is I'm going to turn this little triangle here into an example. All right, so example. If I tell you that this side is 6. I'm just telling it to you. It's there, it's in the problem, or you know it or can figure it out. Once you know that, you can actually figure out the other sides of the triangle. And there's a couple ways to do this. You can just memorize it. And that's basically what I've done after years of just working with it. So this is x. This is x root 3 because it's across from the 60. And the hypotenuse is 2x. Well, if x is equal to 6, then 2x is going to be 2 times 6. So this would be 12. And if x is equal to 6, then this side would be 6 root 3. And that's how you use the 30, 60, 90s if you're just dealing with a simplistic problem of figuring out the sides of the triangle if you know one of them. Okay? So that's the 30, 60, 90 special right triangle, and it's based, in my estimations, the easiest way is to base it off of an equilateral and just drop an altitude down. If we look at, and we're going to go over to 45, 45s now, 45, 45, 90 special right triangle, the easiest way to find this one is I want you to think about a square. Okay, so a square, let's see if we can draw that, close enough. All 4 sides are congruent. So if one side is x, all 4 sides are x. And all 4 angles are right angles. So far, so okay? Okay. So we're starting with a regular quadrilateral. All sides and all angles are equal. Now what I'm going to do is draw in the diagonal. Now the diagonal in a square bisects the 2 corner angles here. So if you bisect a 90-degree angle, you create 45-degree angles. Oops, not 44, 45. There we go. So off to the side, I'm going to take a second and just redraw part of this. Okay, so I'm going to do a little triangle on the bottom here. So we know x, we've got our 90-degree angle, here's 45, here's 45. Now, what I don't know is the length of the actual diagonal. And so just like in the 30, 60, 90, I use Pythagorean theorem, I'm going to do the same thing here. All right. In this case, I am going to use c as my unknown. So x squared plus x squared is equal to c squared, because remember it's leg times leg squared plus leg squared equals hypotenuse squared. So 2x squared is equal to c squared. I am going to take the square root of both sides. So c is equal to, break this up in pieces. I don't know what the square root of 2 is. Well, my calculator does, but I don't off the top of my head. And then I'm going to do the square root of x squared, which is just x. So that tells me that the hypotenuse of this triangle is x root 2. So if we're looking at filling in the little box of information, if the angle is 45, the side across is x, which again, it's actually not going to matter because this is an equilateral. No, I said it wrong. This is an isosceles triangle. So these 2 base angles being congruent means the 2 sides are congruent. And the side opposite of 90 is x root 2. So I'm going to do a quick example, just like I did in the last one. So for example, if I know that one leg is 10, just real straightforward, it's 10. And I want to find the other 2 pieces of information, the 2 sides for this triangle. Well, I know the legs are both x, so that means the other leg is 10, and the hypotenuse is x root 2, so whatever x is, multiply it times root 2. And that's, again, how you can find those really simplistic problems dealing with 30, 60, 90s. All right, I'm going to go ahead and cut the video here. This, again, was just to give you an introduction into the 2 special right triangles. The next video is going to take the 30, 60, 90 and 45, 45, 90 and figure out all of the trig values for those angles, the 30, the 60, and the 45-degree angle.